Hi everyone, in this video we will be discussing the Boyle's Law lab. So as always, you enter into your lab Blackboard site, into the lab material, scroll to the lab you want to open up. In this case, it's our last lab, so yay, we have reached the end of the labs, and I mean the end of the class overall, so a big kudos to everyone for all your hard work and all your efforts as a student. I really appreciate it, and I really enjoy getting to watch everybody grow and learn as a chemist. So, in this lab, we are focusing on Boyle's Law. You have your links and then the pre-lab videos. A few of these are actually irrelevant. I need to delete those, I believe. Well, if they're relevant, they'll be there when you're watching this video, and if they're not, they'll be gone. So you'll open up your links, which I have already done. This lab is, I think, very simple. You're probably rolling your eyes like you say that every time. No, I do think this lab is pretty simple. It focuses on only one of the gas laws, Boyle's Law, not any of the other ones. And you basically test some different volumes, measure the pressure, and you get to see the relationship. So as you have studied from the chapters, you learned how gases have 4 characteristics that affect their behavior, which is volume, pressure, temperature, and the amount. And by amount, we mean moles. And whenever you want to study, just the least that you can study at a time is 2 of those variables at a time, 2 of those characteristics. The other 2 have to remain constant. So for example, here we are studying pressure and volume, then that means that moles and temperature, that took me a little bit, would stay constant. So keep that in mind, that it's not that we're ignoring the other 2 characteristics, it's that they're staying constant, so we can really focus on pressure and volume. So this is the relationship. This is Boyle's Law. P1 times V1 equals P2 times V2. So this is a inversely proportional relationship, meaning that if one goes up, the other goes down. What do we mean by that? So if pressure increases, then volume decreases. So if pressure increases on this side, volume will decrease right there. And you have 2 sets where you have one condition over here, you have another condition over there. This is very, very similar to your M1V1 equals M2V2 dilution equation. Keep that in mind. So in terms of like solving for algebraically one of these terms, that's the same. So if you know how to do that, you're good. So what are we doing in this lab? You, like I said, are changing the volume of a sample of gas, and then you're measuring the pressure, and you will get to see Boyle's Law in action. So what are we actually doing in this lab? You're doing 2 experiments. One has to do with the P and the V for propane, and then the other is for butane. So you're repeating the same exact experiment for number 2 that you did in number 1, except with a different gas. So that's the good thing, is that once you are, confident with experiment 1, you'll just go easily into experiment 2. It won't be a big deal, nothing too different besides it being a different gas. So some things I wanted to point out is you actually did something very, very similar in the intro to the simulation lab. I'm nodding by myself right now. I know you can't see me, but I'm thinking back and trying to remember. I'm pretty sure it's that one, but either way, you have done something similar to this. So keep this in mind and really pay attention to the fact that the Erlenmeyer flask, it says it's 250 ml, right? But that's for liquids, and that's for the markings that it has. But the overall volume inside that Erlenmeyer flask is larger than 250 ml, right? It has space above those volume markings. And because we have a gases take up the volume of containers, then that means the total volume is 314 when you have just the gas in there and it's sealed tightly where nothing is escaping. So keep that in mind. But from there, you'll also be using a graduated cylinder once you get your Erlenmeyer flask set up, and I'm going to show you how to do that. And then you are going to be adding in increments of water. So notice that as you add in increments of water, you are slowly decreasing the volume of the gas, right? Because you're taking up that volume and replacing it with water, which is not a gas, okay? And you keep on adding water, you keep measuring pressure, right? It tells you record the new pressure value. Continue to add in increments of 20, and make sure to read the meniscus. And you're going to continue all the way up until 100 ml. Okay. And it tells you record, with each increment of water, calculate the volume available to gas. So that's what I was mentioning, how if we add in 20 ml of water, we are decreasing this 314 by 20. So basically, how much water you have, you're subtracting that from the 314 to get the volume of the gas. Okay, so once you read through the procedure, you go ahead and open up the lab. I went ahead and did that. So let's talk about how I assembled this and how you get here. So you bring over your 250 ml flask. That's what I did. And then to seal it, to close it, I double click it and then click close, and you'll see that it has the little stopper now, so it's fully sealed. And then you can add in your pressure gauge, and you can add in your gas from there. So here I'm actually gonna start with a fresh Erlenmeyer flask. Let me just move this over. Got my Erlenmeyer flask. I have closed it. I have added my pressure gauge. And you can change the units if you want. And then you are going to add the correct gas. Remember, experiment 1 is propane, experiment 2 is butane, and then there's some more gases here, but we're working with propane and butane. And it lets you add in pressure. So I can add what the experiment told me, which is 1 atm, right? And you'll probably notice that it said 1 atm. So the atmosphere is also 1 atm. So before we put in the butane, it had just atmospheric gas in there, and we replaced it out once you put in that butane. So just keep that in mind. And then you would start measuring out your water, adding in your water as needed, depending on what step you are on. But I just wanted to quickly remind you about reading at the meniscus, making sure that you have the correct measurement of volume. Remember to read the meniscus, you can just double click the graduated cylinder. Other than that, it's not too complicated. Just make sure to record as always and keep track of what you've done. You can label, for example, if I wanted to keep my Erlenmeyer flask for butane and, not throw it away yet, or you can do them side by side. You could do the butane right here, have another Erlenmeyer flask set up for your, I said butane, I should have said propane. Propane goes first, or actually you can do either one. But yeah, just make sure to label them so you know which gas you're working with, because that's a different parts of your experiment. Experiment 1 is propane, experiment 2 butane. Okay, so you did hopefully record all your measurements, and at that point, and once you finish your both experiments, at that point you're ready to do the lab assignment, right? So this lab, you do have measurements in the previous lab that you worked on pH indicators was super qualitative, but this one you are recording some measurements, so keep that in mind to the correct sig figs. And then some qualitative questions about, you know, the relationship, what relationship you just witnessed or observed. And we talked about that a little bit, right? So we talked about how it's an inverse relationship, hint, hint. So keep that in mind, that you always have the background section to refer to. Just looking through these questions, just double checking that I don't want to go too in depth, because like I said, this lab is a little bit simpler. Don't mind that. That was just the announcement I sent earlier. Nothing too informative. So one question I did want to show, this one. So remember I mentioned there was videos here. They are relevant, so they will be there. So this is how to create a scatter plot. What does that mean? It's just a graph where you plot some data points, and then what you can do is add in a line of best fit. Now that line of best fit, you can generate a trend line. So remember from algebra, y equals mx plus b, that's what you're going to generate. And from that, you can extract some information. So basically here, what this tells you is you are going to extract some information from the slope and from the intercept. So make sure to follow these videos step by step. I have both the Excel version and the Google Sheets version, because I know some students use Google Sheets. So use whichever one is relevant to you. And like I said, step by step, pause the video if you need, you need it to go a little bit slower. Do whatever you need. And then you can just, a sentence or two about what you think, whether this data verifies Boyle's law or not. And then these are some questions you can answer based off of your trend line. So the good thing about having that trend line is you can plug and chug, right? And you can plug in any X value that you want, or solve for. You can also solve for these just using PV equals P1 V1 equals P2 V2. There you go. Yeah, but don't stress too much about this lab. I know there's more questions, but yeah, I think it's a little bit simpler than some previous labs. So enjoy your last lab. Again, you're probably rolling your eyes. Enjoy your last lab, and it was really great to have you as a student, whoever you are that you're watching it. I hope everybody watches this. And again, thank you for watching, and reach out to me if you have any questions. We're almost at the end. You will make it.